Okay. So anyone to tell me like what exactly this chapter is all about? Chapter 2. Yes.
It's like motion, velocity, acceleration.
It's all about motion. It's all about motion in one dimension, right? It's all about motion in one dimension. Like what is what is the meaning of one dimension in a straight line, right? So you can have motion along a horizontal path, like a car moving this way, or you can have motion which is up and down. So you have both of these kind of situations. And we will go through each and every example for highlighting some of the important stuff regarding horizontal motion, vertical motion. Okay. And while studying this, you went through some of the equations, right? I, in fact, derived all the equations for you. So you don't have to know the derivation of the equations, but at least you should remember those equations. What are the equations of motion? Does anyone know it by heart? If you use it multiple times, it will automatically get in. Vf is equal to Vi plus At. Now that's an equation that comes through the definition of acceleration. What is acceleration's definition? Vf minus Vi over time. This is the average acceleration. The average acceleration is Vf minus Vi over time. So if you know how fast you were moving and then how fast you are going up to, in what time, that will tell you the average acceleration, correct? So if a car is picking up a speed, you call it pickup. It's able to go from 0 to something in a certain time. And that is average acceleration, yes.
Are we going to have to know these by heart?
Yes, you have to know it by heart. Now, later on, if you're going to use these equations, I can give it to you. But this is a test on equations of motion. So your equations are supposed to be important. Yes?
First one.
Vf is, which one? This one or that one?
That one.
Vf is equal to Vi plus At. This is the final velocity. That's the initial velocity. That's the acceleration. That's the time. Did we use this equation before?
Yes.
Yes. So this is final velocity, initial velocity, acceleration, time. Then we have the other equation. Displacement is equal to final velocity plus initial velocity over 2 times time. What is this part? The bracketed one here is called the average velocity. This is the average velocity times time is equal to displacement. That's our next equation. And then we also saw this equation, VIT plus half AT squared. Yes?
These will be the equations that we'll use like on the test and how to set out. We have a word problem.
You don't have to show how these equations are coming, but you're going to use those equations, yes. You saw all those different exercise questions that you went through as homework and all that. You use these equations already. Anyway, we're going to see more examples of those, so it should be okay. X is equal to VIT plus half AT squared. This is your next equation. And the last equation is Vf squared is equal to Vi squared plus 2AX. Now, if you see these equations multiple times and use it multiple times, it will automatically get into your system, right? Equations of motion. If you try to look at this equation carefully, yes, you'll see that x is missing from here. Acceleration is missing from here. Final velocity missing from here. Time is missing from here, right? That's one point. The other thing you can also notice here is this equation has no numbers in it. Can you notice that? No numbers. This equation has a 2 down here, used once. This equation has 2 2's. There's a 2 here, there's a 2 here. This equation has 3 2's. So in case you kind of mess up with the number of 2's, then remember, no 2's, 1 2, 2 2's, 3 2's in the equation. Make sense? Yeah. So some way or the other, you have to try and memorize these things. And so imagine you wrote all this and you're confused on this. Then you can understand, like, all right, so there's supposed to be 3 2's in this, so I have to put the 2 there. Anyway, practice it. Practice it and they should be all right. So these are the equations of motion, and these are the equations of motion used for accelerated motion. Only when there is acceleration we use it. For non-accelerated motion, if there is no acceleration, what do you mean by no acceleration?
Constant speed.
Constant velocity. If something is moving at a constant velocity, what's the acceleration? Zero. So if I look into a graph, look at this graph. Suppose something is going like this. This is the velocity time graph. What's happening from here to here? It's accelerating. Why? Because it is inclined. What's the slope of this line supposed to give you? Slope of velocity time graph gives you?
Acceleration.
Acceleration. So what's the slope here? 0. And how do you find slope? Rise over. So you can see how much is the rise and how much is the run, and you can find the slope. What's the slope here? 0, which means what? What's the acceleration here? None. 0. And here it's accelerating again. What's happening here? Deceleration. It's coming down. So every stroke on a velocity time graph has to make some sense, and you should be able to connect to it. So if it is not an accelerated motion, what's the acceleration? 0. Put 0 in this equation. What does it tell you? If you put 0 right there, Vi equal to Vf, Vf is equal to Vi, right? That's obviously understood. If something is moving at a constant velocity with 0 acceleration, constant velocity means it moves with the same velocity all the time. So you can't have a final and an initial. It's going to stay the same, right? So if Vf and Vi are the same, then imagine this is V and this is V. If Vf and Vi are the same, this is V, this is V. So that will become 2V. 2V divided by 2 is V. So x is equal to Vt. X is equal to Vt. This is the only equation you're going to use for non-accelerated motion. For non-accelerated motion, the only equation you're going to be using is that. Only one equation for no acceleration. You can see that from here also. Look, put A equal to 0. In this equation, put A equal to 0, this whole thing goes. So what is left? The same thing is left. Put A equal to 0 here. It tells you Vf square is Vi square. Yeah, obviously understood that also, right? It's the same. So there's only one equation that you can use for non-accelerated motion, and that is this. But for accelerated motion, we have to use one of these. Which one you're going to use depends on what is given and what is missing. What is missing? What information you don't have? If you don't have any information of x, then use the first equation. If you don't have any idea of acceleration, then use this equation. If you don't have any idea of final velocity, use that equation. If you don't have any idea of time, use the last equation. Okay? Let me know if you have any questions as I'm saying this. Okay. We have those equations. Now, looking into some problems which are actually on the horizontal side. Let's say you traveled from point A, city A, to city B. You traveled, and let's say you went through a distance of 270 kilometers, and you took a time to travel 270 kilometers. Suppose you took a time of 3 hours and 20 minutes. If it took 3 hours and 20 minutes to reach there, what's the average speed? What's the average speed? Now everybody must work with your calculator as we are doing it. I'm not going to do all the calculations. You do the calculations and let me know.
I'm gonna go with my calculator.
Average speed is, what's the formula for, what's the definition of average speed? Total distance over total time. What's the total distance? 270 kilometers. Divided by what do you get? 84. Is that everybody's answer?
81.
81. How much? So what did you put as a time? As a time?
Okay, 3 plus 1.
Yeah, it is 3 hours. So you okay? Make sure that the entire time is in hours, not hours, minutes, seconds, and all that. You can't do that. You have to put everything in hours. Okay, because we are trying to find out in kilometers per hour. So everything should be in hours directly. So 3 hours 20 minutes. How do you change hours to minutes to hours? Yeah, 20 minutes is equal to how many hours? You know how to convert it, right? Minutes to hours. The unit is going bigger by how many times? 60 times. So the number should go smaller 60 times. So we have 20 divided by 60, which is basically 0.33 hours. So what is the total time here? It is 3.33 hours. Now you do the calculation.
81.
Yeah, 81 point?
Same.
81? 81 kilometers per hour. 81 kilometers per hour. Now how many meters per second is that? If you have to change kilometers per hour to meters per second, there's a shortcut. Just divide it with 3.6. Divided by 3.6. Shortest way to get it. So you don't have to sit and convert the whole thing. So what do you do? 81 divided by 3.6 will give you the answer in? How much is that? 81 divided by 3.6 meters per second. How much?
21.5.
So when you divide kilometers per hour with 3.6, what do you get? Meters per second. When you multiply meters per second with 3.6, you get kilometers per hour. Okay? That's the shortest way of getting it. So now we saw how to find the average speed in kilometers per hour and in meters per second. Yeah.
Where'd you get the 3.6
It comes from the conversion of both of these. 3 kilometers to meters is 1,000 times bigger, right? Like 1 kilometer is 1,000 meters, and then 1 hour is 3,600 seconds. So we get the 3.6 from there. So 3.6 is an overall effect of converting kilometers and hours together. So sometimes it's easier to kind of get the meters per second from kilometers per hour straight away. Any questions on this? Okay. And let's say you went from city A to city B. And you had a lunch break over here. You took some lunch break of 1 hour. And then you returned back to city A. Suppose you return back to city A at an average speed of at an average speed of 20 meters per second. How long did it take for you to return? You're returning back at 20 meters per second. How long did it take for you to return? What equation can you use here? Question is asking for time. What's the only equation for non-accelerated motion? X is equal to Vt, right? So you know the X already. How much is the X? So T is X over V. X is 270 kilometers. Now what's the speed? Speed is 20 meters per second. Can I use that meters per second over here? No, I need to convert it to kilometers per hour. So what do you do then? Multiply by 3.6. So multiply this with 3.6 and then you will get this one as 72 kilometers per hour. Now you can divide it and that will get you the answer in hours. How much is that? 270 divided by 72. 3.75 hours. Now, all these concepts are required in order to be successful. So I'm just touching up every concept. So you should, I'm not saying the same question is there, but I'm saying the concepts that I used are here and there. Okay? Yes,
How'd you get t equals x?
from this equation.
Oh,
I just divide both sides by v. So x is vt is the only equation. You
okay.
just manipulate that equation to get the time, yes.
Did the hour break that do anything?
No, that doesn't do anything to do with it. No,
Is that just there?
it's just there. I'm going to use it now. What is your average speed for whole trip? Now that's my next question. What's the average speed of the whole trip? So you're going that way with a certain speed. We already found out. How much was the speed? 81. And going back, you're going at 72 kilometers per hour. What's the average speed for the whole trip? Go ahead. Everyone should work. I don't want anyone to just sit and wait for the answers to be thrown on the board by somebody else.
Would be 76.5 kilometers per hour.
What did you do?
I just took the speed from kilometers per hour from the first part and added it to the second and divided it by 2.
What is the definition of average speed? Total distance divided by total time. You have to stick to that. Yes, it's a very common mistake of taking the two speeds and dividing by 2. No, that is not average speed. Average speed by definition is total distance over total time. Average speed is the total distance over total time. Yes?
66.8 kilometers an hour.
I don't know exact numbers, but what did you do?
I just took
What's the total distance traveled?
540 kilometers.
540, yes.
And then
What's the total time?
should have 8.08 hours.
Possible, because 3.33 hours here and 3.75 hours over here and the 1 hour. Did you add this?
Yes.
So you have to take the total time. Total time. It's 3.33 plus 3.75 plus the 1 hour halt that you did. You did all this in 60?
66.8.
Okay. You write it down also to be easy. You'll be able to focus better. Alright, so you got that. That's how we find the total distance over total time, which is the average speed for the whole journey. What's the average velocity of the whole journey? What's the average velocity of the whole journey? What's the average velocity for the whole journey? Come on, come on. What's the average velocity by definition?
Oh, 0.
0. What's the average velocity by definition? Total displacement divided by total time. Average velocity. What's the difference between speed and velocity? Speed, distance. Velocity, displacement. So what is the average velocity? Total displacement over total time. Total displacement means what? Total, like how much you got shifted all together. You were here and now you're here back again. So you have not been moved. So the displacement is 0. So the average velocity is when you throw something up like that, what exactly happens to the velocity as it goes up? What happens to the acceleration? Can you tell me what happens to each and every piece of data? And I throw something up. What happens to the velocity as it starts moving up? It decreases. Velocity decreases, right? To 0 on the top. And then starts coming down in the negative direction. What happens to the acceleration? What's the acceleration when it's going up? What's it when it's coming down? Top? Good. Top also is negative 9.8. So acceleration due to gravity is going to be always the one which is controlling its motion because we are in gravity. Yeah.
What's the equation for average velocity?
Average velocity is total displacement over total time. All right, let's say a car was moving at 10 meters per second. A car was moving at 10 meters per second. And then he steps on the gas a little more and he accelerates up to 25 meters per second. And during this acceleration period, he traveled 100 meters. So what is the acceleration? You see, whenever you're given any question, the best thing to do is to kind of picturize it like this. Just imagine this is a car. And then this. And this is how fast it's going. What do you do now? Write down the data. What data can you write here? Initial velocity is what? 10. What's the final velocity? 25. What is the displacement? 100. What's asked? And what is not given? Time is not given. So what do you do next? You find the equation which is missing in time. Which equation is that? Yes, Vf square is equal to Vi square plus 2Ax. Write that equation down. Don't just imagine that equation in your head and then start substituting. That's where things go wrong. Many students do that mistake. They understood which equation to use, but that equation is hanging in the air. And then they are trying to put the numbers. That is wrong. Write the equation down. Doesn't take much time. And then, making sure that the equation is right, plug this thing in. 25 square is equal to 10 square plus 2 times acceleration times 100. Once you write it down, then you will process it gradually. What is 25 square? 625. And then you have 100 here. Plus 2 times 100 is 200, so 200A. And then subtract 100 from both sides, you get 525 is equal to 200A. What is the acceleration?
2.63.
2.63 meters per second squared. You get it? You see, typically an equation that, a problem that we have solved, it's a car that is accelerating on the road and you're given some details and you're supposed to find the acceleration. See what we did. We listed all the data and then we found out which is the information that is missing completely, and then you went back to the equation and picked up that equation which is missing in that variable. There it is, and then substitute to get the answer. If you do things in an orderly fashion, you will get to the answers better. If you're in a hurry, there's a chance that you make mistakes. Very simple, very casual mistakes possible. I'll give you another example of a car moving at 15 meters per second, steps on the gas and accelerates to 20 meters per second in a time of 3 seconds. He steps on the gas and in 3 seconds he reaches 20 meters per second. How far did he travel in that acceleration period? So what do you do with this problem? Write the data down. VI, what is VI? 50. What is VF? 20. What is time? 3. So we have 3 pieces of information. Oh, it's 3. 3 seconds. Now what is displacement is the question. What is a missing?
52.5.
Possible.
Acceleration.
Acceleration is missing. So what do you do next? Immediately go to the equation which is missing in acceleration. What is that equation? Yes. So the best way to study these equations, this is how it is. Just think, okay, which is the equation that's missing? Blindly just look at it. Okay, which is missing in time? And then you will be able to recognize that equation. Say it. Which is missing in acceleration? Say it. Which is missing in final velocity? Say that equation. And like this, you practice a couple of times, you'll be okay. And then substitution. X is what is asked. VF, 20 plus VI, 15 divided by 2 together times time, 3. And so the answer is
52.5.
52.5 meters. Okay? You're standing on top of a building, 50 meters tall, and you're throwing something down at 10 meters per second. How long does it take for it to reach the floor? See, I'm drawing this picture right now as I'm saying, narrating the question. But remember, these pictures are not going to be there when you read the questions. So you have to do that imagination part. So how does this actually read? An object is thrown down from the top of a building, which is 50 meters high, at a speed of 10 meters per second. Find how long it takes to reach the ground. So look for data now. The next thing after you know this thing is pick the data. What is the initial velocity? Negative 10. That is right. And if you are in a hurry to not worry about the negative signs and all that, see, a positive and a negative makes a huge difference. What do you mean by positive 10? You're throwing it upward. Positive 10 means you're throwing it this way. What did I say? You're throwing it downward. When you throw it downwards, the initial velocity is negative. So if you instead put positive, you're going to get a different answer. You understand this? Okay, acceleration is what? And displacement is what? 50? Negative 50. See, every time, be careful. Why is displacement negative 50? Because it started here and ended below. That's why. Now, if instead you put positive 50, you're inviting trouble again. Because positive 50 means you threw it like this and it ended up there. You see? Doesn't make sense. So make sure that you put your symbols, the signs in front of those numbers first carefully. That's where care has to be given. And then what is the question asking? For time. Now what is the information that's not there? Velocity final is not there. So pick an equation which does not have final velocity and use it. So what's the equation?
VIT plus half AT squared.
X is equal to VIT plus half AT squared. That's our equation. Now what do? X is negative 50 equals to VI is negative 10, so negative 10 t, times t, and then plus half of acceleration is always going to be negative, right? So negative 4.9, what? T squared. Yes, VI times t. T is something which you don't know. Plus half a. Half of negative 9 point is always going to be negative 4.9, so t squared. What do you do from here? You can't do it by t because there's no t here. There's no 50 here. I mean, there's no t in this 50.
I'll set it equal to 0.
Huh?
You said it equal to 0?
You have to set it up equal to 0. So what you do is, you have to set it in equal to 0. In other words, push all the variables to one side, leave one side 0. So this is what happens when I add 4.9 t squared to both sides and I add this one to both sides. This is going to be a final equation. Now, do you understand how that equation comes? Everyone. Because you see, that's equal to sign and that's equal to sign. There are two terms on this right hand side. I pushed both of them to this side. So now it has turned into what do you call this equation? What is the name of this equation? Where you have a square and a single term starting with q. It's a quadratic equation. Now you have to solve this quadratic equation. How do you solve it?
Quadratic formula.
The quadratic formula. What's a quadratic formula? Alright, so you should know that because not all questions are going to be straightforward, like linear equations. Sometimes you may end up with a quadratic equation, you have to solve it. Yes, so quadratic, how many of you don't have an idea of quadratic equations? Absolutely no idea. Have you done it before? Yeah, if you've done it before, then that's what I'm asking. Have you heard this term quadratic equation? Have you done in math some quadratic things? Yes. No?
No, since freshman year.
You should have done quadratic stuff because that's part of the ACT requirement also. You should have done the quadratic format. Well, this is called the quadratic format. Ax squared plus bx plus c equal to 0. If an equation comes in that format, now a, b, and c are numbers. If you have x squared plus bx plus c equal to 0, this is not a linear equation. This is called a quadratic equation. What you need to do is you got to factorize it. Now, if it is something that can be factorized, yes, go by the factorization method. And these are things that you're not going to factorize. Especially when you have 4.9 and all that, you're not going to factorize it. It's not easy. And so what do you do? We apply the quadratic solution for this. So x, you're going to solve for x. And x is what? This is the format. If this is b, this is the equation, minus b, plus or minus root of b squared minus 4ac over 2a. That is our quadratic formula. That is something that you need to use here. Now, if you have not learned it, learn it right now. This is the quadratic format, and this is how we solve for that x. Now, if I give you a linear equation, you know how to solve it. Now, this is just not linear because there's a square and then there's a single term here. So it's because we have the square term, this is the quadratic format. Yeah.
What does the B and the C
B,
stand for?
the B stands for the number that is in front of this variable. The A is the number that stands in front of this variable. And the C is the number that has no variable next to it. So look at this equation now. Can you see the A?
Yeah.
Can you see the B? B is the number that sits next to the single variable. And that's the C.
So now we just plug it in.
Oh, now it's just plug it in. So once you know that this is A, this is B, this is C, and then you just plug it in. So what are you solving for? Not x, but time. So time is equal to minus B. What's B?
10.
10. So negative 10. Plus or minus root of B squared. So 10 squared. Minus
4.
4 times A times negative 50. So when you have a minus and you have a negative 50 coming in, it will become a plus. Alright? So what is 4 times 4.9 times 50?
980.
980. Divided by 2A, 2 times 4.9, which is 9.8. So we are almost ready to solve it. So now it is plus 10 plus or minus square root of, this is 100, so it becomes 1080 over 9.8. The next step, minus 10 plus or minus, what is square root of 1080?
Is that 980 negative?
No, it's plus because there's the equation had a minus sign already there, and the C was a negative 50.
32.
So is the A
A is positive.
positive 4.9?
Yeah, A is positive.
This is negative.
Okay.
There's no negative sign here. Yeah, don't look at this equation. This is not the format required. You have to bring it to this format. Then you work it out. Okay, so you have plus or minus. What is square root of 1080?
32.
30?
Two.
2.9 over 9.8. Now, now you have two solutions. If you take plus sign alone, it'll be minus 10 plus 32.9 divided by 9.8. Tell me that answer. If you only choose the plus sign.
2 points. 2.4.
So minus 10 plus 32.9 is 22.9. 22.9 divided by 9.8 is 2.34 seconds. Now when I take a minus sign alone, what you have is negative 10, negative 32.9 is negative 42.9 divided by 9.8 gets you a negative number per time. Throw it away. You don't take the negative time. So you only take the positive time. The negative time comes out around like negative 5 point something, right? So you get negative 5.4 or something like that, throw it away. Why? Because we don't want the negative time. So that is your answer. So that stone is going to reach the ground after 2.34 seconds. Get it? Now, what would be the difference if I throw this upward?
Be positive.
It'll be positive, and if that is positive, then this is going to be a positive number, and that will be a negative number. So you'll have plus here instead of minus. That's the only difference. Plus, plus, plus. And then, because it is plus, you have to use the positive sign again. So you will get the time. So when you throw something up, that's what you do. Okay? If I really throw it upward at 10 meters per second, if I threw something up like that at 10 meters per second, how high did it go? That's a question. If I threw something at 10 meters per second, how high did it go? I'm throwing it at 10 meters per second. How high did it go? Okay, so the question is asking you, how high did it go? It went like that. Question is asking you to find out how high it went. So you basically need to know that point, right? So between here and here, let's list the quantities. What is VI? 10. Positive 10 and negative 10.
Positive.
Positive because it's up. What is acceleration? Negative 9.8. What else? What else do you know? Between these 2 points, what else do you know? What is it? Displacement is the question. Displacement is the question. The question is, how high did it go?
The building. Final velocity.
The final velocity, do you know?
0.
0. Final velocity is 0. Why? Because it is turning around. You know, when I throw something like that, what is the velocity on the top? 0. So between this point and this point, the final velocity is 0 on the very top. There you go. And what are you trying to find out? X. So what equation of motion are you going to use? The one which has no time. So we have square is equal to VI square plus 2AX. Now substitute 0 square is equal to 10 square plus 2 times negative 9.8 times x. So zero equal to 100 minus 19.6x. What you can do now, add 19.6x to both sides. We get 19.6x is equal to 100. So what is x? Hundred, zero is 100 minus 19.6x. So 19.6x is 100. What is x? 5.1 meters. So if I threw something like that, it goes up to 5.1 meters before it turns around. Do you get it? So if I threw, if I threw that stone from the top of the building, what's happening to the stone? It's going up, then coming back and hitting here. What distance did the stone travel? If that is the question, what do you do? Tell me how far the stone traveled. What's the distance traveled? Distance traveled by stone. What is that?
60.2.
Yeah, 60 point, yes. How do you do it? It's 5.1 going like this, 5.1 coming back here, so it's 10.2, and then from there to there is another 50, so 60.2. You get it? So to find the total distance, you need to know how far it went up. So that's how you do it. So how high did it go last time when you threw something at 10 meters per second? 5.1 meters. Now if you do the same thing on the moon, then how high will it go? So let's do it on the moon. So if I'm throwing something at 10 meters per second on the moon, how high does it go? So what do you need? So this is how it goes on the moon. So again, back to the same spot. So what is the piece of data that you have? Vi equal to 10. What is Vf?
0.
What is acceleration? So you need the acceleration on the moon. So the acceleration due to gravity is 1.5 meters per second square. So what do you write here? Negative 1.5. Don't take positive. There's no planet where there's a positive acceleration. Okay? There's no planet where things will fall that way. Everything's going to go this way. So acceleration, even if it is given to you as, okay, it's only 1.5 meters per second squared, you have to substitute the negative sign while solving it because you know it's going down. The question is asking for that. So do the same thing as what you did last time. Tell me what answer you get. Last time we got 5.1 meters. Do exactly the same thing. Quickly. These things should not take more than 30 seconds if you're doing it. So practice these kind of questions. And make sure you are speeding up in the
33.3.
how much?
33.3 meters.
So x will be 33.3 meters. Looks right to me. I don't know. Check it and see. It's correct? So if you're looking at this, if this is the scale, let's say here, on the earth, you throw something at 10 meters per second, it goes up to here and comes back. See? Goes up to here and comes back. On the moon, if you throw the same object, it'll go up to here and comes back. Got it? All right. Going back to the same question again. You're throwing the object at 10 meters per second on Earth. After how long will it return to the thrower? After how long will it return to the thrower? You heard the question right? If the object is thrown at 10 meters per second, how long does it take to return? Every time you have to make sure you get the picturization right. So here's the picturization. Now then look for the data. What is VI? 10 meters per second. What else do you know? Acceleration is known. What else do you know? We don't know the final velocity here. Do you know the displacement? Do you know the total displacement?
I know 0.
Look,
0.
0. Because it went up and came back to my hands. So it's not displaced at all. It was here and it's here. Not there. So it's here and then it comes back to my hands. So the total displacement is 0. Did you understand that part? So if it is thrown from here and it comes back to the same spot, x is 0. And the question is asking for time. So once you picturize the whole thing, once you write down this, then you will get to the answers. Yes?
I thought the final velocity would be 0.
No, final velocity is the velocity with which it hits on my hand on its return. See this? If it's hitting me, what speed is it hitting me with? That one. The final velocity is the velocity with which it lands, not after landing. Get it? The landing velocity. So if I throw it like this, look, did it come and hit with the speed? That's what it is. Final velocity is not after it hits, just before it hits. That's the final velocity. Okay, so what equation will you use here? Something that doesn't have final velocity. X is equal to VIT plus half AT squared. Substitute now. 0 equal to 10t. Yeah, plus half a, which is negative 4.9 t squared. What do you do from that point? Once you have that equation, what do you do from there? You organize it, yes. What do? You add 4.9 t squared to both sides. So 4.9 t squared is equal to 10t. Now this is not a quadratic equation. Did it look like the quadratic equation? There's no number. There's no number next to it, so it is not a quadratic equation. 4.9 t squared equal to 10t. What do you do from here mathematically?
Divide by t.
Divide both sides by t. So if you divide both sides by t, one of the t's get knocked off. You see it? When you divide both sides by t, one of the t's get knocked off. What is left now is 4.9t is equal to 10. And what's the answer?
2.04.
2.04. So it takes 2.04 seconds to reach. So if I throw something like that, it reaches back after 2.04 seconds. If I throw it at 10 meters per second though. You get it? A car traveling at 30 kilometers per hour accelerates at 1.5 meters per second square to a speed of 40 kilometers per hour. How far did it travel? How far did it travel? Now, this is traveling with an acceleration of 1.5 meters per second square. So you have to write the data down, pick the correct equation, and work. How far did it travel? Anyone has any ideas of how to start off with it? Yes.
Change the 30 and 40 kilometers per hour.
Yes, you have to change this to meters per second. If you continue to work with that, that is wrong. Because acceleration is given meters per second square. How can you use kilometers and hours along with it? You cannot. You have to use only one system of units. So what is initial velocity? 30 kilometers per hour. You can't use that. You have to change it to meters per second, which is? How do you get kilometers per hour to meters per second? Divided by 3.6. What do you have? 8.3? 8.33 meters per second. What is final velocity? 40 divided by 3.6, which is 11 point. 11.11 meters per second. So you have final velocity. Acceleration is now 1.5 meters per second squared. So once you have the proper units applied, then you can find out this x. Time is not given to you, so you have to use an equation of motion, which is vf squared equals to vi squared plus 2ax. Substitute 11.11 square equal to 8.33 squared plus 2 times acceleration of 1.5 times x. Now, carefully deal with that and then get the answer. Anyone?
18.2.
Is it 18.2, everybody?
18.02.
So is it 18 meters? Okay. So, yeah, around there. Yes, 18 meters is the total shift.